All right, so by looking at the graphs, it looks like x is -3. So because just by, oops, I can't use the stylus. Because every single one of them is that same thing, right? If they were different, then, you know. Anyway, so that helps to know that. However, we're going to go ahead and do the, show the work. So go ahead and, do the x equals opposite b over 2a. So we want to find out. And I'm sure that you're not extremely happy here that a is a fraction. -1/2. It's not a big deal because it's going to cancel out, you'll see. And then b here is -3. Go ahead and do the math on that.
Okay. Okay.
So 3 over 2 times -1/2. 2 times -1/2 is -1. So 3 over -1 is going to give us x equals -3, which we knew from looking at the graphs. But the thing that we want to know to be able to get the rest of the question is what is y? So we're going to plug in -3 in place of x. So go ahead and do that. Okay, so y equals, you put in -1/2. Oops. I'm not saying right or wrong, okay? I'm just checking it out. Okay. -3 squared minus 3 times -3 minus 4. You just put that straight up in your calculator, right? So -9/2 plus 9 minus 4. So let's see, 5. Yep. So 1/2, 0.5. So y equals 1/2. So we just have to look which one of those. Back here. Okay. Which one of those is 1/2 above the x-axis? So, well, these two are out, right? They're below the x-axis. That one's a little bit too high, so that would be your winner, right? Winner, winner, chicken dinner. All right. And so I'm going to figure out the domain and range. All right. Okay. Number 10, error analysis, our favorite kind. Okay, so let's look at what happens. Let's look at how we should do this to find the axis of symmetry. So to find the axis of symmetry is just x equals whatever the x, so x equals opposite b over 2a. Okay, so we're going to come up here, we're going to find b is -12. Don't forget the negative. And a is 3. So first, do the math on that. All right. So when we do the math, we get x equals 2. So let's look over here at what the person did here. So they did x equals opposite b over 2a. So they did negative 12 over 2 times 3 equals negative 2. So what did they do wrong?
They had negative 12 instead of positive 12.
Yeah, they didn't do the negative. So let's look at which one fits that. The substitutions for B and A were reversed. The substitutions for B and A used the wrong values from the equation. The negative sign from the formula was forgotten after substituting negative 12 for B. The fraction was simplified incorrectly after substituting the values for B and A. It would be which one? Got it? So
Yep.
the negative sign was forgotten and corrected it. The axis of symmetry is indeed x equals 2, like we said. All right. That's the next assignment. Let's see, we're on 11. There we go. Modeling with the mathematics. Okay, so the function shown represents the height in feet of a firework t seconds after it is launched. The firework explodes at its highest point. So here we go. So this, if we look, this is a parabola, right? And the vertex is the highest point. So any frowny face parabola, its vertex is its maximum. That's another thing you're going to see at some point is the maximum. And that would be the y value for the maximum. Okay. So, and you look at, and this is a really good example of why that is your maximum, because that's the highest, right? And it's also, I mean, it's a good example of why you would use y, because y is the height. Y is, you know, in this real life example, the height. So, and then t, they're using t, you know, for x, right? So this is really the same thing. They're just using h for y and t for x. Okay, so just kind of keep that in mind to keep us from getting too confused. But so t, okay, t. So we're calling x t, and that is the time. They're using t for time, and that's in seconds. Okay, so if we want to know how high it is, we're just going to use our x equals opposite b over 2a. And we're going to find, that's going to give us x. That's going to tell us how many seconds. So it's going to give us that first one. So a is negative 16. B is 128. So use those to find x. So we got 4 seconds. It took 4 seconds. And then for this next part, what height does the firework explode? So what do you think? What are we going to do to find what height?
Plug in 4 for t.
Yep, plug 4 in for t. Perfect. And then find out the height. So plug in, whoops, over for t, and you get 256 feet. I gotta probably scroll down. It probably says that, but so it's always important if something is being asked in words to answer it in words. So you would make sure you would say 256 feet, which is exactly what you did. Perfect. All that. At what height? Yep, there it goes. Okay. Next, the cable. Hold on. The cable between two towers of a suspension bridge can be modeled by the function shown, where x and y are measured in feet. The cable is at road level midway between the towers. How far from each tower shown is the lowest point of the cable? How far from each tower? Lowest point. Oh, okay. So it's the lowest point. That's kind of like. At first, I was like, "Are they talking about distance between the towers?" But they're not, and that's good because I was like, "Wait a minute, I'm not sure." All right. So first, let's just find the vertex. Okay, so this point right there is the vertex. So we're going to do exactly what we've been doing and say x equals opposite b over to a. And so a equals 1 over 400. You thought those other fractions were bad. Yeah. And b equals. And then what does b equal? Since it's minus x, what number's hiding there in front of that x?
1.
Yeah. So b equals -1. So to plug that in, we're going to go opposite of b. Hold on.
So
b is 1 over 2, and it's 2 times 1 over 400 is going to be 2 over 400. Okay. So remember, when you put this in your calculator, you want to put 2 over 400 in parentheses.
I know.
Yeah. I guess it is how far from each tower, or it's like in distance like that. That's different. I think maybe what they're doing is like using this would be 0, 0. Oh, let me do it different color. So maybe pretending like that 0, 0. Yeah. Oh, I see now. There's the y-axis. So hold on. I see the y and x-axis now. I didn't see them before. So there's that. They're calling that the y-axis, and this the x-axis. So that's good. So if x is 200, then the lowest point of the cable is 200 feet from each tower. Okay. And then how high is it above the water? So the water is x. So we have to plug 200 back into that y equals, to find out what that height is. So y equals 1 over 400 times 200 squared minus 200 plus 150. So plug that in and see what you get. So when you plug all that in, you get 50. So the road is 50 feet above the water. So now for the domain and range of this function, this one doesn't go forever. There are no like arrows, it ends. So if this is 200 feet from here, it's also 200 feet from there. So that's goes up to 400. So X would go from 0 to 400. And then let's see for Y. Well, it's got to go from 50 up to, and then right here at 0, if you plug in 0 for X, see what you get if you plug in 0 for X. Y equals 1 over 400 times 0 squared minus 0 plus 150. So you're going to see what that is. So what happens is this number out here, let me get my thingy. This number out here is your height. I mean, so whenever you have that in that form, zeros are going to make those first two terms go away. So whatever number that is out there, that is the height. That's like the starting height or whatever. So the lowest point was 150, and then this highest point is actually given in the equation is 150. When you plug in 0, you find that out. So 50 is less than or equal to Y is less than or equal to 150. So your range. Okay.